So I'll go quickly through a bit of our ecosystem, just that we get everyone on the same page. I'm not spending too much time, and then I'll jump to the actual use cases. And I have some use cases prepared, and then I have some reserve, so depending on the interest. And as always, ask questions or challenge me if you want. Okay. So before going to the products, so just an overview. So what are the basic elements that we have on IP delivery workflows? So it doesn't matter what is the vendor, who is the manufacturer, but okay, usually you have encoder, something that converts from baseband to something that is compressed. We also have, of course, then decoder doing the same thing the other way around. And okay, we can have a gateway, like I've shown you already, something that is just acting as a gateway, transmitting between different places. And we could also have a transcoder. So how does this translate in Haivision world? So this is just a brief categorization. So of course we have encoders, we have the Makito series, we have the rack series, we have the mobile transmitters, those are also encoders. Then as the gateway, as the name says, we have SRT gateway. We also have Stream Hub that I would put it also into the gateway and also to the transcoder category. And then on the other end of the chain, we have Stream Hub that can also be the decoder and Makitos. So our position in these workflows is that we try to focus on the contribution side. We are not that much present in distribution side or distribution encoding side. So sometimes it's also that, okay, why doesn't Makito do X, Y, and Z? It's really, we have to choose our battles, where we put our focus and what do we develop further. Just some examples of our transmitters. I also have a few transmitters here. And then this is more on the Makito side. So Makitos, they are hardware-based encoders and decoders, usually used as contribution links. I say they're quite reliable. The best I've seen is that a Makito uptime has been multiple years, that it hasn't been touched. It's just gathering dust somewhere and it's just sending a feed. So that's, I always find it a nice example when a customer says that. And I have an example of a Makito also here. It's a really small one. It's encoder. Also, really important product is the Stream Hub. I see the Stream Hub as a universal decoder, because with Makito, it's a hardware-based. It has its limitations. What type of feed it's able to receive, what is it able to decode, all that. With Stream Hub, it's basically the Swiss Army knife. You can mostly throw anything into a Stream Hub, and I would say like 95% of the chance it's able to decode it. So that's a really it's a really flexible platform in that. SRT gateway, I already showed you that. So I'm not focusing too much, but a nice feature also with the SRT gateway, what we see on the workflows is network bridging. So you have your multicast network on one side, you have a multicast network somewhere else, you need to bridge that. Quite often we see that is being done with SRT and also with the SRT gateway. That SRT gateway is ingesting those multicast feed, sending it as SRT, and then on the other side, it goes the other way. So from SRT to multicast again. So instead of having to use a managed network that supports multicast, so we see this more and more, and also as a distribution point. So I'm ingesting my feed, and I need to distribute it to multiple recipients, like we saw in our little Play Pro demo example where you participated. So good. And the final part is Hub 360, which is basically our cloud management and orchestration tool on that. So then let me show you some example workflows, what we are seeing, how SRT is being used and how our products are being used. So the simplest one, a fixed contribution to a studio. So you have a camera, you have an encoder, it's sending an SRT over public internet to a decoder somewhere. So I think you are all familiar with this type of workflows. And of course, we are also seeing this same workflow also with SST as well. So then doing this, but adding some more additional elements, making it more complex. For example, having returns video in the play. Of course, with return video, I'm seeing more and more WebRTC being used instead of SRT to get the latency down even further, because there the key is the latency and not the actual image quality on that. And the most common example with the SRT gateway is then a broadcast distribution. So I need to distribute my program feed for 20 affiliates all over the world. I need a place to do it. I need to control the encryption. I need to manage it. So this is also really common use case, what we are seeing here. Then going a bit further, so this is more on the remote production side. I have an actual example of this as well. That instead of having the full production crew out in the field, you only have the cameramans, and all the actual production is done centralized. So here we are seeing a huge adoption of our mobile transmitters, that you can have remote shading of cameras, you can send a return video, you can have additional elements here as well. And similar setup then with Makitos, that you have multiple video sources that you need to transmit in sync to your production. You need to decode it, you need to provide that to the production and use it. And I think I mentioned that with SRT and Makito, with SRT, there's a feature that you can timestamp your signals, and then that timestamping can be then used on the decoding side. Yep. No. Any public or private, what you are able to reach.
It's not the same on both sides.
It can be a different one, yeah, because if in the end it's based on a universal atomic clock, so then it should match quite closely. But still, I would say that then coming to the actual hardware implementation, like with Makitos, I say that this alignment, it's frame accurate, it's not phase accurate. So you still might have plus or minus 1 frame difference there. Yeah. So like some customers have tried to use this type of setup with sending graphics, fill and key. But for me, it's like, no, that's not good, because you still can have a variance in that. So yeah, but for like just for camera angles, ISO feeds, we are seeing it used quite a lot. And also, it's not dependent on a single encoder and decoder, so it can scale indefinitely. But you still need you need to use the same latency figures with all of your devices in the end. No. Okay, few more examples on the remote production. So this is again a combination on SRT and also SST in this case. I'll have some more actual use cases coming up soon. And let me see, are there any other relevant? Yeah, well, this, we've done a few of these setups that you have basically all editing workstations are centralized somewhere, but then the editors have to be, well, wherever they are. And then they need low latency feeds to see, low latency and high quality feeds to see their work. So there we have seen also these type of setups. Okay, so I think that's enough on these examples. Let me go to these. Okay, so this use case, customer case, is from the Paris Olympics, and this is with Warner Brothers Discovery Eurosports, and I don't know. Let's see what's the future name, Netflix or whoever is buying it now. Then, so the problem that Warner Brothers had is that they went to OBS that, okay, we need to have 35 stand-up positions. What's the price of the SDI circuit, or what's the price of the fiber circuit? And of course, OBS came back with a totally crazy price tag, tens of thousands of euros per position. And then Warner was that, okay, let's look for another type of solution, what we can use. And in the end, they ended up building rack cases, flight cases for all these positions that contained Makito encoders, decoders. And then only having a 50 Mbits public internet line in each of the stand-up positions. So, and with this, they were able to achieve the same results as if they would have a fiber circuit or SDI circuit. But the cost savings were 90%. It was like totally insane. So their return on investment was instant. What they had, and they are using the similar setup then with the upcoming Milano Cortina, and actually they are expanding the setup as well there. So in the end, it's a really simple workflow. We have encoders, we have decoders. And they are sending or receiving the SRT feeds. It's nothing special, but of course it's a nice scale, and it solves a customer problem. So I like this quite a lot. Good. So another example I have is this one. I cannot say who. This is just being deployed. So this is basically for news contribution, news production, and it's a combination again of Makitos, a combination of mobile transmitters and stream hubs. So, and what made this difficult? No, not difficult. Challenging. Yeah, challenging. Yeah, is that everything needed to be UHD 4K. It's like, okay, fine. So of course, everything is 4 times more heavy. The channel density is much less. You just need much more equipment everywhere. So in the end, it's a combination of Makito decoders for receiving some external feeds. Same way using Makito encoders for distributing those same feeds or the production feeds out over SRT. Then from field contribution, it's a combination of mobile transmitters, Mojo Pro, our mobile application for SST, going to stream hubs, and they receive return video feeds then from these encoders back to here. And then again using Stream Hub as the universal decoder and also a bit of a multi-viewer for receiving third-party random feeds all over the place. So yeah, this was a nice challenging project in that sense. Okay, one example I have also here is with Riddle and with private 5G. So this is not, it's not purely SRT related, but it's part of our ecosystem. So I wanted to highlight this as well. So we're seeing more and more private 5G deployments in different events, and then using our mobile transmitters instead of regular OFDM video links. So this is also a nice example. Okay, let me jump into the rest of the examples. Let me see. So yeah, I'll start with this one. So this is basically a remote production use case from Denmark. This was done, I think it was last year. So basically, so Minitech, they are a rental house, a production services company there. So basically what they needed to do was just to produce a small rally event. So in total, only 5 cameras positioned all around the track. Production was 174 kilometers away in Viby. I have no clue where it is in Denmark. I need to look it up. And basically, all cameras had a mobile transmitter. They also had a Cyan View converter box that they were then able to have camera shading through that and our data bridge VPN, let's call it that way. No private 5G, nothing special. They were using public networks and each camera just producing 10 megabit H.265, and it was a good, only 800 milliseconds there. So I have an example of the end result, basically. So.
På ydersiden her, men jeg tror ikke, Kasper han var sønderlig glad for den der. Det var vist lidt en bump and run, tror jeg, man kalder den. Touringcar-kørsel. Hårdt.
Så var han bytter.
So just looks like a simple production. Nothing too special on that. But what they were able to do is minimal setup time. Only the cameramans with the 5 cameras, okay, they set it up and they were ready to go. And this is what we are seeing more and more on that people are doing more and more remote productions and like also like centralized productions that gathering all the contribution feed into centralized place, and then they have dedicated people working in shifts producing the content on that. So 4 cameras with mobile transmitters, and one was using an SRT encoder, and this was the diagram of the production. So they were, let me see. So they were also taking the tally information, sending that through the Cyan View RCP, and then all the cameras also had the proper tally. And of course, with the Cyan View, then they were able to do the shading of the feeds as well. And intercom, I think that was. I don't know how they used intercom in this case. Okay. Yeah. Okay, that was that. Then I have a fun one. Yeah. So this was actually January of last year. So this is 1 year old. So now the whole situation about Greenland is again a topic, but it was already a topic a year ago. So TV2 Denmark is a really long-time customer for us, and they are really, I would say, call them the guinea pigs. They are giving us feedback on our product roadmap, and they are testing the new stuff. But this was something that we were not involved at all. So they set up this totally by themselves by just using the equipment that they had on the shelves there. What they wanted to do was basically a round table where half of the people, here you can see on the top, were in Nuuk in Greenland, and then the other half was in Copenhagen, and they were having a panel discussion. So they was basically setting up two studios with mirroring sets that they then composited together and were able to cut. So we have, so this is the example. So one side of the studio in Nuuk, the other one in Copenhagen. And an example of the end product that they were then producing. So that was quite fun. And then looking at it from the production mixer, that they did all the mixing and the producing in Copenhagen for this.
Gule breaking overskrifter med vilde udmeldinger, ekstraordinære pressemøder. Det er stor politik, og det er også store følelser. Det skal vi tale om i aften på begge sider af Atlanten. 1:25.
I er super gode, Julie.
Yeah. And, okay, this is the same. Few more shots here as well.
I er super gode, Julie.
So, and here you see the the mess that is behind the curtain every time. So basically, they used a bunch of our transmitters. They had a single leased line, 100 megabits between Copenhagen and Nuuk, and they needed to fit everything into that then. And our encoders were used for the transmission. Well, yeah, here's the explanation on that. And I think they had a good round-trip time on that. And then, yeah, backup connection, just whatever public connections they had. And then talking about the latency, that, of course, it's nice to discuss that, okay, this encoder, this has 100 millisecond latency, and this one has this much on the decoder, but what is the latency then end-to-end? Because you have the video mixers, you have the multi-views, you have the embedders, the embedders, it all adds up, and then it all needs to be managed. But anyway, I'm quite surprised actually that even with this high latency, they were able to have a good panel on this. And yeah, and then they used small cameras. The video return, for that I think they used a WebRTC, and it was quicker. And then they used our transmitters for the actual contribution feeds. And so here's the setup, if you can see it. So quite a lot of it was also done outside of our products. All the audio and intercom was used separately. There's lots of Glen sound stuff. And we were a small part of that workflow. But, and now they're setting up a more permanent setup there, that whenever something goes crazy again, that then they're able to react. Let's put it that way. But yeah, I thought that this was a nice example considering the crazy times we are living at the moment. Okay, let me see, what else should I show you? Okay, I'll talk briefly on this as well. So this was a quite a massive setup what we had in the Paris Olympic Games. So the idea was to use mobile phones and also our app called Mojo Pro to be able to contribute feeds from the opening ceremony boats on that. And in total it was 85 boats. We had a 220 Samsung S24 devices, and those were all rigged into the different boats on that. So just as a logistical challenge setup, it was quite a huge undertaking. And for this, a private 5G network was set up along the river, and then there were a bunch of antennas then installed on the different bridges to provide the coverage. So here you can see an image of the master control room where all the feeds were monitored. And what we were also able to do here was to do camera shading with each individual mobile phone. So, okay, we could change the exposure, we could change the camera from the back to the front, all these things just to make the image viewable, to be ready for the production. There were, what we found interesting was that the phone's endurance, the actual battery was not enough. We had to use an external battery, but the only connector in the phone is USB-C, and USB-C is not that waterproof. So, so we've noticed a number of occasions that, because later on in the opening ceremony there was lots of rain, like always, Murphy's Law or something like that, and some of the phones had just shut down the USB port to protect its own circuitry. So then we've lost maybe 20 phones for that. So that was an interesting challenge. Yeah. A similar thing we did also with the mobile phones was with sailing. But in this case, we used the mobile phones only as the transmitter. And we were using also external USB-C cameras. So, especially with this type of sailing events, that there isn't, you cannot put nothing too heavy on those sailing boats. It's just, you can't put an FX6 there. With a huge transmitter and everything, it's yeah, it's impossible on that. And here you can see some different ways we had rigged the phones. And of course, its own challenge that when it's about sailing, it always depends on the currents and the weather and the waves. So the whole network was floating. It was based on 3 different catamarans creating the bubble there. And then the catamarans had their own radio backhaul in high frequency to the shore. And from there, then to the 5G core, and then to the actual stream hubs with the decoders. So this was a really interesting and challenging project, and we got the IBC Innovation Award with OBS with this one. So I'm quite proud of that one as well. Okay, then let me show you some more. This is another still on the Olympics. So this was in Tahiti, so where they had the surfing event. So in the end, it was a really simple setup. They had a private 5G bubble set up there on a big crane, and then just a mobile transmitter that they were able to move around freely and produce their stand-ups and stuff. The funny thing, what happened here was that they had a rented, they had a dedicated line set up between Tahiti and Paris, but that line broke down. So in the end, they had to transmit directly from our transmitter, then to the private 5G, then to the public network, and then to Paris. So I find it quite interesting, and then a nice way to see how resilient is the transmission and the protocol as well. So yeah. Okay, let me show you this example as well. So here we were basically using our mobile transmitters instead of OFDM transmitters. So we were using them in ultra low latency mode. We had end-to-end latency of 100 milliseconds. The bit rates we were using, they were quite high because we were also doing it in UHD, so about 45 megabits. And then just being able to have the comparison, how does it compare with the existing OFDM? So we could have gone down already to 80 milliseconds, but because of the existing wireless camera links, they were set to 100 milliseconds, so then we matched our equipment to that as well. Yeah, so few conclusions what we got from Paris. Yeah, so I think it's quite nice and impressive. As well. Okay, so that's it for the use cases. I can show you a bit on our devices a bit more because I didn't do the demo part there. So hold on. So I'll start on the Makito. So I have my Makito here. I have my video feed. So it's configured to be 10 megabits. Oh, let's do it 5. Yeah, and then I want to send this to my gateway. Yeah, here. Yes, so, okay, this is going. Yeah, so now I'm sending from my encoder that I have in Tallinn, I'm sending my feed all the way to Frankfurt, here, and now I'm able to view it, of course, or send it somewhere else. Or I can actually receive it on my decoder. Yeah, let's do it this way. Let me see. Oh. Yeah, so now it's a nice simple workflow. So we are ingesting video here on my encoder. Then I'm sending that to my gateway. So here I see what's the latency, what's the RTT, all that. I see it on the gateway. It's the same statistics basically. And then I have my output connected to the decoder, and then it's SDI or 2110 or whatever is needed. So a simple workflow, what we've already basically done a few times. The same way I can of course do it with StreamHub. I can create an SRT input. Actually, I should have one. Yeah, so SRT in. $10,000, no, 10,001, yeah. And then I can assign this, let's say here. Oh, I already had an SRT in. And then I can start this. I can copy the URL and actually let me send it from the gateway. I'll add a destination here. Yeah, and let's see, is it, oh, now I'm receiving the same thing also in StreamHub. Also in StreamHub, I have one transmitter actually connected there. And okay, it has to be the same video source, but okay, I can start the live here as well. And then I can see what's going on. Okay, now it's 20 megabits. I can see I have only 2 modems. I can increase the latency if I want to. And then, of course, I can send the same thing out now as, let's say, SRT. and then I can access that with some other tools. Or I can just decode it here on, because these are my SDI outputs, so I can decode that as well. So just a really simple, really quick glimpse on the Stream Hub as well. There's additional features. Okay, I have my multi-viewer here. I can change how it looks. I can assign different inputs. Let's see. Let's see if the NASA feed works. Okay, yeah. So I can ingest different things. This is just an HLS simple feed as well. And then, of course, I can take this output now, and I can play it myself in VLC.
Actually became public immediately the moment we saw it, and we got this email.
Yeah, so really simple, really quickly. It's possible to make quite complex workflows on that. So, okay, any questions? Well, then I thank you.